Hello and welcome. My name is Mohammed Hassan Bannour and I'm going to be your instructor in this video. In this lesson, we will learn about parameterizing reports in R Markdown. Think about when you have to generate multiple reports for, let's say, multiple years at once. If you do that manually, it will take you so much time. And you will repeat yourself doing the same tasks. And when there is repetition, there is potential for automation. In this lesson, we will learn how to leverage R Markdown and R capabilities to generate multiple reports for multiple instances, for example, for regions or for years. We will also leverage R Markdown and R to keep the consistency and the reliability of the analysis or the data or basically any kind of information you would like to convey in your report. Let's dig in. You can pause the screen here to discuss and discover more the learning objectives of this lesson, but they are mainly for faults. First, we would like to understand and discover what does it mean to parameterize reports in R Markdown. Second, we will learn how to create these dynamic reports using these specific parameters. And finally, we will develop the skills to create specific functions for this and leverage functional programming with the purrr package, specifically by using map and pwalk functions in our processes. As for the packages, we are going to use few of them. Basically, we are going to use three main packages. The first one is the tidyverse. It is a meta package that contains other packages within it. We will use some of these packages, mainly dplyr, ggplot, and netar. Also, we will use purrr, which is a package that allows us to do functional programming, and gt, which is a function that allows us to create beautiful tables in R. You can load these packages with this function, as I will do right now. Now that our packages are loaded and ready to go, let's take a look at our data. Our data is a compilation of multiple countries and multiple years that target specifically HIV incidents. So we have basically three columns. The first is the name of the country, the second is the year, and the third is the number of new HIV cases reported for that given year, for that given country. So we can go ahead and run our data, and if we run again, this is what it looks like, and it's exactly what's in the description. To dig deeper into this lesson, we will start by one single report for one single country. We will use the case of Angola. The idea from this report is threefold. First, we will focus on visual reports, basically creating plots and graphs. Second, we will also analyze these trends in the graphs. And third, we will focus on the trends of these new HIV cases. So, in order to attain our objective from the report, we need to start by the first output, which is the line plot for Angola. And the way to do it is to start from our initial data, filter for Angola, and then visualize the year and the new cases. So the way we do it is we take our data, as you can see here, this is our data. And then what we do is say filter country equals Angola. Now, once we do that, we can pass this subset of data to ggplot, and we can simply say ggplot and pass the aesthetics where we say put the variable year in the x-axis and the variable new cases in the y-axis. And once we have that and we run this code, voila, you have this really nice plot ready. Our second output is a table. We will use GT for this. And to start with, we are going to filter the data by country. So we'll say country equal Angola. And we will identify the most recent year, and that by saying Angola data, and then we access by the $sign the year colon. Once we have that, we can go on to the table part. Again, we will use GT. You can refer to our lesson on GT. It's really good. So basically, we will take the Angola data like this, and we will pass it to the GT function. We will use the type style function to style our table, and we will specify in these functions to use a specific color in a specific column in a specific row. The way to do it is we will define two parameters in the type style function. The first is style, and for that we will use cell fill. So fill the cell with the color light blue. Location, where to do that? We tell go to the body of the table, find these cells where columns equals year, and rows, this is where we specify exactly where in rows, and in rows we say year equals most recent year. So after that, we simply use the tab header function from GT to add a title, summary of HIV cases in Angola by year. And when we run the entirety of this code, we end up with this table. And if you scroll a little bit down, you'll end up with 2009, which is the most recent year, being highlighted. So yes, it is that simple. Now that we have two outputs, mainly the graph and the table, we can create sort of a demo report that contains just both of them. To do that, we need to follow some steps. Now I'm going to simply go through these steps, but we will explain them in the next sections. First, we will need to create a new Markdown file with those inputs. We will need to write a YAML header for that Markdown file. We will add a data preparation section that prepares the data for us, and a section where we generate the plot and the table, and finally all we have to do is knit that Markdown file. In this section, we will actually create this report. We will embody the DRY principle. DRY stands for do not repeat yourself. The idea basically is that we are going to create a function that generates all these elements, the plot and the table and whatever you actually want in your specific report. We will create this function that we will call generate country report. This function, if I can select it properly, which embodies the DRY principle and basically centralizes repetitive tasks through that function. The DRY principle is a fundamental software development principle that focuses on minimizing repetition. The idea is if you have a repetitive task, you don't keep doing it. You streamline it in a way that you do it only once through a function mainly or an object, and you keep using that throughout every time basically you need to access that function or to access the output of that function or that module or whatever. Basically, the idea is to have a clean code that focuses on the most important aspects of the output you need to have, and basically streamline or eliminate any kind of repetition or redundancies to other functions or modules. This is our function, and in this function we pass two parameters: the data parameter with our data and the country name with a specific country name that we want to analyze in our report. Basically, this function creates one plot and then creates one table. But to do that, we need to do some data preparation. We will get into each specific component of this function in details right now. So to start with, and as I said, we start by declaring the function through naming it and then assign it to function with the parameters. And in this function, we will take two parameters, and within these curlies, we add the rest of our code. Next, we plot the data. And to do that, we start by filtering the data. So we take the data that we have, which is HIV incidence with all the counties and all the years, and we filter that data to the specific country that we have. Notice the curlies between the country name argument. Those curlies are not necessary, but they are very, very recommended to use them with dplyr functions like filter or select, or even here with paste, so that it's clear that we are going to take that argument as a character and not as a variable within the code itself. So again, we filter the data for the specific country name, and then we pass that data to ggplot and access the year and the new cases in the axis, and we simply add this title line where we basically incorporate the country name in the title so it's clear. Lastly, we print the object P, which is the plot that we just generated. In our case, we can add an optional step, which is basically creating a summary table. But in our case, we don't really need that because the case is already summarized. We have Angola, years, and the indicator, and it's kind of straightforward. But in your case, if you need more specific subsetting of your data, feel free to do that as well. This is the exact moment and the exact part where you should probably do that. Since that we already generated the plot, at least theoretically within the function, we can move on to generate the table. And to do that, we might need to specify the maximum number in the year column. This will allow us to specify the most recent year. We simply run this line, and we not really run it, but basically we add it to the function and we use it later on, and that allows us to access this specific value. And now that we have the maximum value from our year column in our data, we can take that data and pass it to GT. Basically what we will do is to tell GT to color the most recent year, as we already explained that, and basically you take that code and you assign it to the table output object within the function, and later or finally we can print this function by simply using the function print. And then when you run that function, the generate report function, it will allow us to print both the table and the graph. Now, imagine you have multiple instances like countries or regions or time period, specific periods that you need to analyze. It will be tedious to generate these reports over and over, even if you have a function. And here comes the purrr package. The purrr package, through its functions, allows us to basically map through, or rather iterate through some kind of a vector, and that vector or list allows us to apply the function, the generate country report function, for example, for each country. So basically, if I supply a list of countries that are within our data and then map our function generate country reports through these this list of countries, I will have the output of all these countries in a specific file. And that's basically the objective of this lesson. So say, for example, we want to create a report for Angola, Nigeria, and Mali. It's kind of tedious if you have more than that, but even these 3 examples, I'm kind of lazy. I don't want to copy and paste 3 times, honestly. If I can do it in one run, I'm gonna do it in one run. So the idea basically is to create a vector, as I said, and then map the function generate country reports to these countries. The idea is, since that generate country reports accepts 2 functions, those are data and the country name, we have already the data there as a parameter, and for the country name, that's the value from the country's vector, and that's why we put a dot here. That means take the value from the country's vector. So for each country, it will run that function. So this is the equivalent of saying generate country report using HIV data for Angola, generate country report using HIV data for Nigeria, and generate country report with HIV data for Mali. So if you have more than 3 countries or more than 3 instances, let's say 20 or 40, and you want to go through all of them, this is the best way to do it. And this complies with the dry principles. In order to build our parameterized report, we need to start by few configuration. One of the most important ones is the YAML header. The YAML header is the first part in your Markdown file. It basically specifies the title, the date, the authors, and many more, and many other parameters as well. The idea here is to identify which parameters we want to use and specify, and then go from there to generate our reports. An example of a YAML header in our context is the following, and as you can see, this header contains the title, the output format, which is HTML in this context. You can create PDF document if you want, and additional parameters. For example, we will specify that for this report the country is Angola. The idea is twofold. Basically, we specify the document title and the desired output through the title and the output arguments in that YAML header. Second, we specify specific parameters. In our case, we use the params, this one, the params parameter, and this allows us to define other parameters. For example, in our case, we specified in params country equals to Angola. This means that under the parameter params, a parameter named country is declared, and that it will control which country's data is being used in the report. Additionally, the Angola declaration, it's the default value for the country declaration, and that means that if we do not specify which country we're going to report on in our document, the default is going to be set to Angola. The idea basically is to define the parameters that are going to be used throughout the entirety of the code, but right in the beginning. So basically, but by specifying that country is Angola in the YAML header, we can access that specific parameter and use it in the function calling for generate country report. For example, in here we can say generate country report using our data, whatever data it is, and then use params $country, which means access the country parameter, the value of the country parameter in the params header, in the YAML header. So basically, since we specified that the country in the params parameter in the YAML header is Angola, this is equivalent to saying Angola. And the way to access that value is to specify the params parameter with the country parameter, and writing this basically allow us to access that specific value. And this is very useful, especially if you want to automatize the generation of the report itself. When we adapt our R Markdown to these idioms, to this way of generating the reports, we create a great adaptability for the report, which means that with the same YAML header, we can generate the same report for a different subset of the data, and that enhances efficiency, versatility, and also the reproducibility of the information. And this is very important if you are basically spending lots of time doing these parameters on your own. Let's show an example on how to use the parameters from the YAML header to, let's say, filter your data within your functions. So what we can say is, this is the filtered data object that will be assigned effective TP data, in which we will say filter country where params, and then we access the parameters within params with the $, and we say country. And since the country is already pre-specified in the YAML header, we don't need to add anything else. Similarly, we can do that with the year if we had already specified the year in the params parameter. What we can say is similar. Go to params in the YAML header, access the year parameter, and bring this value here. That's basically the idea. Now, just like a data frame, when we want to access a specific column, we add that $. For YAML, it's also similar. So basically, we go to the params and access that, access the parameters, and specifically request the values for the parameter name, whatever it is. The idea basically is to make the reporting process dynamic rather than static, because eventually the entire report will use these parameters that you already pre-specify, so that not only that the data is consistent throughout the entire parameter, but also it can be changed fairly easily for each of the reports that you want to make. The idea again is that we specify general parameters in the YAML header, where we put those parameters under the parameter params, and then we name our parameters and their specific values. So when we want to access one value from a specific parameter, all we have to do is to write this command, params $, parameter name. The idea is that to use the $, similarly as using it with a data frame or any R object like a list, for example, it's basically the same principle. We store a parameter somewhere in the header, and then we access that parameter with the $. So since we established that we have multiple parameters that we want to involve in our YAML header for our R Markdown, it's time to learn on the about the multiple ways we can render or knit this document. The major and the most used one is using RStudio to do that. RStudio has amazing functionalities that allows you with a click of a button to basically render or knit the document. Of course, you can access more parameters within the RStudio menus. You can see the knit function or the or other parameter logos, and you press on that, and you basically have access to all the custom parameters with which you can render or knit your document. However, this is not the focus of our lesson, so let's get into more details on how to do that in a different way. This different way is basically using the command line. Instead of writing code, we will write code to knit or render our document. The idea is, through the code, we can actually automatize the rendering of this document. So one example command is basically using the render function from R Markdown. So basically we say markdown ... that means access the render function from Markdown package and render this report using the parameters, the params in the list as country equals Angola. So the idea here, in the params header in the YAML section, we specify that country equals Angola. Now, when we run the code, we will basically have a report that is generated as if we filtered ourselves all the data to be equals to Angola, but we basically specify one parameter in the YAML header, and that's all. The idea here is to leverage this and to automatize the workflow through various tools that we will see in a bit. So, we've been talking about basically creating these small steps. Basically, we created the table, a graph, and then we filtered by Angola, and then we created a small function that generates the same plot and the same table, but we can simply change the filter from Angola to Mali or Nigeria. What is the catch? The catch is that we've been working this whole lesson to come to this point where we piece everything together, from the function that we created in the beginning to the details about the YAML header. These two will allow us to literally create reports without actually having to put more work than necessary. So basically you create a template and you can take that template from one report to another, changing few things in the code, in the core of your output, for example, and you have that basically theoretically for life, but I doubt that. You're gonna do great and you're gonna make your reports better every year. So you might be asking yourself, what's the catch here? We've been talking about parameterized reports, but all we did is basically create a function that gives us two outputs and check how to render RMD files and some details about the YAML header. Well, the idea here is to piece everything together, and together we can basically generate reports that uses the YAML header to render and run the code within the document and give you outputs depending on the specifications that you mentioned within that YAML header. However, when you leverage also the programmability of rendering these documents, you can automatize the entire workflow. And this is basically the whole game. So the way to do this is basically 4 steps. First, we need to create an R projects. This is basically to centralize all the paths in the R project folder. Second, we specify a YAML header, and then we create the R Markdown document, and finally we put all the functionalities, all the desired output into that RMD file. That code will be executed and run once we render the document. So let's get in more details. First, creating an R project. I guess it's straightforward. Basically, when you create an R project within R Studio, what you'll end up having is a .rproj file. Basically, it will have an extension that looks like this, and that's basically your R project file. Now that we have our R project ready and running, we can go with step 1, which is basically the YAML header. As you can see, this is a little bit complicated, but it's quite kind of straightforward as well. Basically, this YAML header sets up the document title, the date, the output format, and defines a state parameter that contains the value Alabama within the params with the params parameter. So basically, when you say params $state, the value will be Alabama. Note that within params, the parameters there is no basic nomenclature. It depends on your needs. It depends on what kind of filtering or what kind of access you want to have. We can put year equals whatever. We can put region equal whatever. It's any kind of subset that allows you to filter your data. You can basically put it there. Once we have our YAML header ready and satisfactory for our needs, we can go ahead and set up the document environment. And what we mean by document environment is basically the data or the parameters that are going to be used throughout the entire document. And these basically are the packages, for example, the data sets, and global setup options like this one, which basically tells R Markdown to not generate or not generate warnings and to not generate messages whenever you run the code, which can be quite handy if you need that in your report. The last step after we did all of this is to create the core and the code that generates the output for our report. In the beginning of this lesson, we created a function, the generate country report function, and this function allows us basically to generate a plot and show it, and also generate a table and then show it. We will revisit this function and change it so that it can be used within our parameterized report. The idea basically is to tell this function to use a specific value of what we've done already. The good thing is, since we already have this function done, we don't have to change much about it. What we have to change though is the way we call it. For example, in here, in the last part of this function, it's an example how to use it. For example, to generate a country report on HIV data for Angola, we simply do this. But in order to call this function from the parameterized report, what we will do is say use this data, but instead of Angola we will say params $country, for example. And when we run this, we will end up having, it's basically the same thing, but it's more consistent with the YAML header that we already specified, and this will allow us to automatize the entire process. Now that our function is basically ready, all you have to do is knit your report to see if there is anything that you have to change, if you made a mistake in the code, if everything is up to your expectations. This is very important, but if you trust your skills, you can skip this. Now, before we start actually crafting and connecting the dots together, in this section we are going to create an R script where the entire parameterization and the automation happen. And in order to do that, as we leveraged the map function, now we're going to use the pmap function, again from the purrr package from the tidyverse. The idea of the pmap function is that it allows us to use a function that contains multiple inputs or parameters, and basically use some kind of a list or a table and put these parameters, put the variables of the table, plug them in within the parameter. So for example, if we have like you see in the picture here. If we have x1, x2, x3, and we have row 1, row 2, row 3, and we want to pass the function to each row. So basically for x1, x2, x3, for the row 1, when we use pmap, automatically the function that we will use will plug in for each of the variables in our table, x1, x2, x3. They will be plugged in respectively for each of the 3 parameters or more if we have more of the function that we have. And eventually we will have for each row a single output. This is the bread and butter of functional programming, and it's very, very useful and powerful to use with R. So we are going to leverage this with the following code. So in order to write the script that will basically allow us to automatize the entire process, we will have to go through basically 4 steps. First, we will need to load the packages, and the packages we need are, at least for this script, are 3, and those are R Markdown, purrr, and stringer. So I'll go ahead and run this. Then I will have to define a vector of countries. In here, I define Mali, Niger, Malawi. I will add, for example, let's say Egypt. Once we have that, we can move on to generate the table. The third level, or the third step that we have to do, is to generate a table or a data frame. I'm going to use table in this case, and the idea basically is to create 2 columns and 4 rows. Each row is dedicated to one of these countries. So basically the idea is that we will have 4 reports, and each report will have a file name, so the name of the report eventually, and each report will have its specific parameters, specifically the country parameter in the params section in the YAML header. So what we want to do is to create these details for each of the countries. We don't have to do them manually, and this is why we are going to leverage functional programming again. So for example, in here we are creating two columns: the file name column, where we have all the file names, and the params column, where we have all the detailed parameters that are going to be used in the YAML header. str-c basically is similar to map in a way. Basically what we have is chain of character like this. It's a string and a string in here as well, and those depict the basic blocks of the name for each of our reports. So basically what we want to say is write country report dash, and then plug in the name of the country accordingly, and then add the extension of the file, which is .html. Similarly, we are going to do the same thing, but to generate the details and the parameters for the params section in the YAML header. And the way to do it is by specifying in the map function that we want to use the countries vector. And once we do that, we will ask R to create a list, and in each of these lists for each of these countries, I would like to say country equals dot, and the dot refers to the input of the map function, which is countries. So basically we are generating a list that contains country equals Mali, country equals Niger, country equals Malawi, and country equal Egypt. This is what we are going to plug in into our YAML header later on. So basically, if I run this, let's see how it looks. This is the reports table, and it is a 4x2 table. For each of the country, we have a report name, and for each report name, we have a list of parameter. And basically, since we only specify that we want country equals to specific value, we will have one item per list. So this makes sense. But we can be more specific. For example, we can say reports and then add a $sign and ask for params. So when we run this, we will have a list because that's a colon list or a list colon. And as you can see, the first value is Mali, the second is Niger, the third is Malawi, and the fourth is Egypt. This is fantastic. Now we can move on. We will use this reports table to generate or to basically specify how we want our files to be rendered using the render function with from R Markdown. So how to do this? So the way to do this is basically to start by understanding how the render function works. The render function takes in as input the file name that you want to render. So let's call our file name, for example, country report. I'm going to write things ad hoc like this, but I'm going to organize them as we speak. So just follow the logic. So eventually we want to use the reports table to generate or to render our report and our file. So, but first, before we start actually writing the code, let's simply break down how the render function from R Markdown package actually it works. So basically, the render function takes in multiple parameters. The most important one is the input, and the input is basically the main R Markdown document that you want to render. In our case, it is the document where we put our function and the YAML header and all the output that we need to see in a document. That's the input. Second is the output. The output is twofold. We have the output directory, which is basically the folder in which we will put our document, and the output file, which is the name of the document that we want to be generated. And this is exactly why we created the file name variable in our table. This variable have the full name for each of our reports. So this will allow us to actually automatize the entire process. So let's start by basically calling reports, and from reports we are going to use file name and params. The only issue is that the render function reads file name as an output, and that output's name, that argument name, is output file. So what we want to do is make or change the file name variable or the file name colon in our reports table to a name that render can understand as an argument or a parameter for that function. So what we can say, and this is a trick in Dipler as well, what we can say is output file equals file name. And when we do that, let me run this line of code. When we do that, we will change the colon name from file name to output file, and this will be used automatically within the render function to generate those specific names. Now, once we have this table ready, we can go and map it and use the render function from R Markdown. Specify that input equals to country report.rmd. This is our fictional report where we put all of our code and the function that we created in the beginning of this lesson. So basically, make sure to save that somewhere. So basically, we say input country report, and then what we can also add is the output directory. And we will specify this as as the name of the folder that we want our rendered files to be saved in. And we will say output slash. So basically, to recapitulate, we used the reports table. We changed the name to output file so that the render function can read it as an output file. And then we specify the input that we are going to use and the output directory. So once we have that, we can simply run this code. And if you have everything properly saved and properly set up, you will end up with 4 reports in the output directory. And each of these reports will have each country's plot and each country's table. And basically you can do that for more than just 4 countries, and you can do that for not just countries but any kind of data subset that you have. It depends on your data and on your objective. And with this, basically we automatize the entire process in a few lines of code. Also, you can also use another function to do the same job of pmap, and it's basically pwalk. So you can write pwalk, it's the same function as pmap. The only difference is that pwalk captures the side effects from all of this functional programming. And since we are writing to disk, it just makes sense to use pwalk, but you will barely notice any difference. So, to wrap up, by the end of this lesson, we were able to create a parameterized report with R Markdown. We were able to enable the dynamic and the efficient aspects of using R and R Markdown within our reports. And we were able to specifically tailor the outputs and the inputs for each of these files programmatically. And these principles are applicable not only for countries, but any kind of data subsets such as regions or time frames. Eventually, we also learned about all of these components and how they come up together in the R script that we use to render all these documents. That's it for today's video. Thank you so much for staying around. Thank you so much for being patient. And make sure, please, to check out all the other lessons and videos and content that we create for you to learn and to know more about R and all the good things that comes with automating data. See you next lesson.
For more resources, visit our website where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.